Equations that contain logarithms are called logarithmic equations. You must be careful when solving these equations because it is possible to get extraneous solutions, meaning solutions that do not work. To solve these equations, you will need to use the various laws of logarithms to get the equation into the right form. Once that is done, you can rewrite the logarithmic equation as an exponential equation. Then just solve for the given variable. However, you have to check and see if your answers are valid. To do this, you just plug them back into the original logarithmic equation, and you don't have to simplify the whole thing. You can just trust that the work is right, but just plug it back in and check and see if it's positive or not. So for the first logarithmic equation, we have 2 log base 5 of x equals 3 log base 5 of 4, and we want to solve this. Well, the first thing is we need to use one of the laws of logs to simplify it. The rule we're going to use is the power rule. We're going to take our coefficients and move them back as exponents. So we're going to get log base 5 of x squared equals log base 5 of 4 cubed. And there's a rule that states that two logs that are equal to each other with the same base, we can just get rid of them and focus on the argument themselves. So 4 cubed, I'm just going to simplify it down to 64. And here we just have this equation that we can solve. So square root of both sides, we're going to get x equals plus minus 8. Now, is this a solution? You guys got two answers. Well, we have to plug it back in and make sure that we do not have a negative within a log or a 0. So first I'm going to plug 8 back in. So we're going to get 2 log base 5 of 8. And I don't need to plug it into the second one because it's all just numbers. I just need to focus on the first one. Well, log base 5 of 8 is some number. 8 is positive, so it's fine. I trust that it's good. So 8 is an answer. Now I'm going to plug in negative 8. So 2 log base 5 of negative 8. I cannot take the log of a negative number, so this is not possible. So my solution of x equals 8 works, and x equals negative 8 is an extraneous solution, so we throw that away. So our only answer here is positive 8. Next we have log x plus log of x plus 15 equals 2. So I'm going to use the law of logs, the product rule, to bring these back together as one log. So since they're adding, I will bring them back together as multiplication. So x plus 15 equals 2. And then I can just change this. Since this is log base 10, I can just change it from a logarithm to an exponential. So this is going to become 10 squared equals x plus 15. And so distribute the x across, and 10 squared going to give us 100 equals x squared plus 15x. And move everything to one side. I'm going to get x squared plus 15x minus 100 equals 0. And I can factor this down to x plus 20, x minus 5. And I solve both of these, and I'm going to get x equals negative 20 and positive 5. So, are these two solutions? Just got to plug it back in and see. I'm going to start with negative 20. So, log of negative 20. And I don't really have to go any further because I cannot take the log of a negative number. So, it's not possible. Now I'm going to try 5. Log of 5, that's fine, plus log of 5 plus 15. And 5 plus 15 is a positive 20, and that is again good. I don't need to go any further because I trust that I did all the work correctly. So the solution x equals negative 20 is extraneous, so it doesn't work. And the solution x equals 5 does work. So this is my only answer for this equation. Last, I have ln of x plus 1 minus ln x equals 2. And since these two logs are subtracting, I'm going to bring them back together as division. So ln of x plus 1 over x equals 2. And so to want to get rid of these, I'm going to exponentiate both sides. Since this is ln, I need the opposite of natural log, which is e. So e ln is going to cancel out, leaving me with x plus 1 over x. But what I do to one side, I have to do to the other. So I'm just going to do e raised to the second power, which is just going to give me e squared. You can get a decimal if you want to, but e squared is just easier to work with. Now I'm going to solve for x. I'm going to multiply the x over to clear the fraction. So I'm going to get x plus 1 equals xe squared. And I have two x's on each side, so I need to move them all to one side. So I'm going to subtract the xe squared over, and then subtract the 1 over to get all the terms on one side. So x minus xe squared equals negative 1. Now I can factor an x out of everything. So x 1 minus e squared equals negative 1. And then divide the 1 minus e squared over. And I'm going to get x equals negative 1 over 1 minus e squared. Now this seems a little bit weird. Got a bunch of minuses roaming around here, so I'm going to actually simplify it. And another version of this is actually going to be 1 over e squared minus 1. So these are equal. I just like this form better. Now, does this work? Well, 1 is a positive number. E squared is a positive number. It's actually a decently large number, just a little bit under 9. Minus 1. Well, something that's close to 9 minus 1 is still positive. This is a positive number. And when I go back up to my original equation, if I take a positive number plus 1, it's going to be positive. And if I put a positive number into the second one, it's also positive. So that's all I need to know, is that these two logs of the beginning, when I plug in my answer, give me a positive solution. So either one of these is an acceptable answer. Again, you can just plug it in to your calculator and just double check, or you can just do it the way I did and just make sure it is a positive answer.